In today's class, we'll be discussing the concept of quantity, units, and measurement. And in today's class, I will carefully break down everything right from the definition to dimension analysis and to measuring instruments of different things. So first thing first is the definition of our quantity, the unit, and measurement itself. So for just so you know, the quantity itself is the property of a body that can be measured. That means if I have this body, that part of this marker that I can measure is the quantity of this marker, right? That is the quantity of it. Now to the unit is that degree I am using to measure this marker. The degree of measurement is now what we call the unit, while the measurement itself is the yardstick or the instrument I am using to measure this marker. I hope you get that now. Now moving on, we have 7 fundamental quantities when it comes to physics. Right from the first one, we have the length. Number 2, we have the mass. Number 3, we have the time. Number 4, we have electric current. Number 5, we have the luminous intensity. Number 6, we have amount of substance. I've written time. Which other one have I not written? And number 7, we have temperature. Alright, now this is just their quantities, right? These are just quantities. Now coming to the unit of each of these quantities, for length we have the meter, which is represented with m. For mass we have the kilogram, which can also be gram, milligram, any kind of gram, but it is still the basic one. It is kilogram. For time we have seconds, which is the basic, but for any other thing you can have hours, you can have minutes, you can have other units of time. We have for electric current we have amperes. The same thing, we can have milliamperes, we can have microamperes, nanoamperes, anything at all. So for the luminous intensity we have candela. For amount of substance we have mole. This mole can also be molar, can also be gm cube or cm cube, right? So we have temperature, which is Kelvin, and this Kelvin, in some cases you can use your temperature to be degrees Celsius or Fahrenheit, but you can always convert when we get there. All right, so we've discussed about the quantity and the unit itself. Now let's talk about dimension analysis. Dimension analysis is the breakdown from which we get derived units from fundamental ones, and the fundamental are the basic ones. Everything comes from these 7, right? Whether by addition, by subtraction, by multiplication, or by division. This is where all other derived units comes in. So for every other unit in such a way that you are adding or subtracting one of these fundamentals, you get a derived quantity or derived unit. Exactly now. So for instance, let's start with the simplest of it all. For distance, let's say for distance, you see you can't find distance here, but you can find length. For distance now, we say a distance covered is by what? The speed, the time taken, and the distance covered, right? Okay, let me say for speed, distance is the same thing as length. Sorry, because when you're talking about anything length, breadth, width, height, depth, they are still under length because you are covering a point A to point B. I believe that is clear. So for distance, for speed now, we say our distance covered, right, over the time taken to cover that particular distance. That is your what? Your speed that you use to cover that particular distance. So in this case now, we would say this distance, which is also a form of length, which will be in meter, right, over our time taken, which will be in seconds, which can also be translated to be in hours or in minutes, right? So if you are given this time in hours, all you just need to do is to bring it back to your seconds by multiplying by 60, or if you are coming from hours to seconds, you just say multiply by 3600. That is 60 minutes 60 seconds. All right, so we have our seconds now. That is where you would say speed is equals to what? Speed is equals to meter per seconds. I believe this is very much clear now. So that is just that about that. So for other dimension analysis, let's go into questions from our jam pack and solve about 4 to 5 questions on this so that you will understand it better. So coming now to our dimension analysis. Just like we said, our dimension analysis is the breakdown of every formula into their basic formula. So for the first thing you need to remember in your dimension analysis is that we have just 3 basic quantities that must be used. We have our mass. For O-level case, we have our mass, we have our length, and we have our time. This is the 3 basic things for O-level sake. But when it comes to A-level, you can be doing your joule, your kilogram, your Kelvin. Exactly. So in other cases, you might use other units. But for O-level sake and for Jambite, you have these 3. And these 3, we basically represent them with mass as M, length as L, and T as time. That's where the MLT comes in. So always remember this, your MLT. Because every quantity you are dealing with will have something related to this. Now let's take our first question. The first question states that the derived unit of pressure can be expressed as. Now, talking about the derived unit of pressure itself. Now, what is the definition of pressure? Pressure is the what? The unit area of force, right? And if you are talking about unit area of force, that means pressure will be what? Force over the area. Now we have to simplify this force and this area in their lowest form. And remember that what? Force is gotten from what? That is if you want to get your force now, remember that your force is your mass and your acceleration, right? So if we come here and say our force is broken down into MA, which is our mass and acceleration, and our area is just the same thing as length times breadth or length times length. Anytime you have anything related to length, breadth, width, height, depth, they are still under length. Don't forget that. So now breaking down this, remember that our acceleration is a product of what? Velocity and time taken, right? So we'll just break that down by saying, since our velocity is what? Displacement. Remember that your velocity is what? Displacement over the time taken. Which displacement is the what? The distance covered in a specific direction. That's the difference between displacement and distance. Specific direction, distance in any direction. Then our time taken, I believe you know that. So we have our what? Our meter over our time taken, which is seconds. That is meter per seconds for your velocity. In this case, and we are still saying our acceleration is what? Over another time. So we say meter per seconds over another seconds, which is our time in this case. So bring that up, we have what? Meter per second square. Now we already got for our acceleration. This is our unit for acceleration. But this is not the dimension for acceleration. If I'm to replace this to get the dimension for acceleration, my meter, which is the same thing as what? Length, will come into be what? L, right? And my time, which is the same thing as t, will come into be t. So I have lt raised to power minus 2. I believe you get that now. So this is just how to get our dimension analysis out of our fundamental unit or derived unit. I believe that is very much clear. So coming over, since we are still going to area now, don't let me clean this side yet. Since we are going to area, we just say, since we already know what our mass and acceleration is, so since we are adding mass to this LT, then we have mass, which is m, multiplied by LT minus 2, which will now give us MLT minus 2. This is for force. This is the dimension of force, right? And we also have the dimension of area, which is L times L, length times length. So that means we have L squared for area. Now, since we know what both of them represent now, we just do our normal mathematics basic calculation by saying, let's bring this L up, right? Bringing this L up, we have what? ML, we have LT raised to power minus 2, then multiply by, carry this one up, this guy is going to change to minus. So we have L minus 2, right? So, and the last part, we just have what? ML, we have 1 L here, and we have minus 2 L here. Minus 1 minus 2, we have what? ml raised to power minus 1 t raised to power minus 2. So I believe this is very much clear, and you understand this when it comes to the dimension analysis of pressure. I believe this is very much clear now. And if you are to bring it to the derived unit now, what will be the derived unit if I'm to change this case? Because in some cases you might not be asked to state it in your dimension analysis, but if you are to use derived unit, remember your mass is what? Kg. That is the unit of mass, kg. Your length is what? Meter. So that will be m raised to power minus 1. Then you have your what? Your time, which is second. That will be s raised to power minus 2. So in this case, this is your answer in derived unit, and this is your answer in dimension analysis. I believe this is very much clear, and I'll see you in the next class. Bye.